Here's the story. Jose wants to travel by boat from Italy to Greece to see his cousin Demetrius. The water level at the destination reaches a maximum depth of 20 meters at 2 in the morning, and then its next lowest depth of 8 meters at 7:30 in the morning. Here is Jose's problem. The boat he's on needs 15 meters of water to dock safely. So we're going to make a graph of the water level at the port on this day. Then we're going to model it using one sine and one cos equation, and then let Jose know if he can come in at 6 p.m. Okay? And then we'll answer this question. It's a bit longer. Okay, so let's start trying to think of a quick sketch of this. If we were graphing the height of the water versus time, and let's work in hours, and this is in meters, then it's telling us this, that we started at 2 in the morning, the water level at 2 in the morning, so let's start at midnight and do it like a 24-hour clock. So at 2 in the morning, which is about here, the height is 20 meters. So I guess it says does it say it's maximum? So high tide happens at 2 in the morning. And then the low tide is at 7:30 in the morning. So 2, 4, 6, 8, 7:30 in the morning, about here, we'd be at a low tide of about 8 meters. And the tide's going to come in, and then I guess it's going to go out again and come in and keep on doing that. And if we're modeling that, we've got some kind of a sinusoidal curve. Okay, so there's just a quick picture. We're going to graph that accurately here. Okay, so let's start here, and we're going to start at 0, and I think I've got enough spaces to make everything 1 hour. 1, 2, we definitely do 2 in the morning, 3, 4, 5, 6, 7 is right here, so 8 would be here. And we're going to have 7:30 in the morning right there. 9, 10, 11. Here's noon, 12 o'clock. And we're going to work in a 24-hour clock, which means 6 p.m. is what time? 18. Okay, so you take noon, 12 hours, and add it to the number. Okay, 12, 13, 14, 15. Okay, ignore the last 2 lines. I guess I made my graph a bit bigger than I needed to. Okay. And then we're graphing the height of the tide, and the max is 20, and the min was 8. Okay, I think I've got enough to do every one. So let's label this. So this was time in hours, and this was the height in meters. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 20. Okay, so really accurately, let's graph his high tide. So the water level at the destination reaches a maximum of 20 at 2 in the morning. So this point. The next lowest depth will be at 8 meters, 5, 6, 7, 8 meters. And that happens at 7:30 in the morning. So here's 7, here's 8, halfway in between. So I have a question for you. When will the tide be back to high tide?
At 53 p.m.
How do you know?
Because It's in between. This one. Is 7.5 is half a period?
Okay, so he just said that half the period is 7.5. How do you know that that's only half? Because you haven't repeated yourself. You've gone from the max to the min. You're not repeating until you get back up to the max. Okay, so what's the length of time it took to go from max to min? Well, look at the times. You've got 7:30 and you started at 2. So what's the length of that half a cycle? 5.5 hours. So what's the length of a whole cycle? So this is 5.5 hours to go through half the cycle. What's a whole cycle? 11 hours. Okay, so the period, 11 hours. How did we get that? 7.5 subtract 2, and we had to double it. Why double it? Because this was only half. Okay, so graph the point where we're back to high tide. I'm going to start here and count out 11 hours. Okay, so this is going to give me 1/2 of a sinusoidal function. But when I graph a sinusoidal function, there's 2 more points I want. I want to know the central axis. How do I know how long it takes to go from high tide halfway to low tide? How many hours does it take? Well, it takes 11 to complete the cycle. I'm asking you how long it takes to complete a quarter of a cycle. 2.75. Okay, very carefully then count 1, 2.5, 0.75. What time are you at here? If I take 2 and I add 2.75, what time is this? 4.75, or if you had to put that into minutes, 4 hours, and it would be at 4:45 a.m. Yeah, 4.75. Okay, what's the height? Okay, we calculated when it would be halfway in between, but what is halfway in between? How do you know?
20 plus 8 divided by 2.
20 plus 8 divided by 2? Sure, 14. We're going to be right here. So we're going to come down, down, and then from here, I guess I got to go another 2.75. Here's 1, here's 2, here's 2.5, here's 2.25, 2 3/4. Back to 14, and up we go. How am I going to count the next one? How about I go 1 cycle, coterminal with this. Add 11 hours. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It'll come back down. From here, add 11 hours. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Coterminal. Add 11 hours. So that was, this was 10.25. Add 11 hours, I'm going to be at 21.25. And from here, if I add 11 hours, this is at 13, I'd be right back to 24. Okay, so there's our tide for the day. And I guess here we could go 1, 2, I need 2.75 to get all the way down. So something like this. It's coming down. So there's a graph, a pretty accurate graph of the height of the tide for that 24-hour period. How are we going to write the equation of that graph? I'm going to graph grade it as a cos function. the height at any time t is equal to A times the cos, B x minus c plus d. How do I find that amplitude? Well, just working through the question, the amplitude is equal to the max minus the min divided by 2 absolute value. 20 minus 8, 12 divided by 2, 6. Amplitude is 6. So the height at any time t, never get it all on the same page, is equal to 6 times the cos. How do I get that b value? B is equal to 2 pi over the period of the function. Okay, that doesn't reduce, so 2 pi over 11. X minus, I'm going to leave out the phase shift for now and add the displacement. How do I get that displacement? The displacement is the max plus the min divided by 2. 14. What's my phase shift? If it's a cos graph, it should start at its maximum point right on the y-axis. Does it? We're going to have to shift this 2 to the right. Okay, so would you please write a sine graph to model this and then graph it in your graphing calculator?